Today on 4.6b, we will be graphing tangent and cotangent of a function. So let's get into it. Graphing tangent and and cotangent is pretty straightforward. What you have to know, kind of like graphing secant and cosecant, is we need to know where our asymptotes will be. And in terms of tangent, it is whenever our cosine of x is 0, right? So whenever cosine of x equals 0, because you can't divide by 0, because tangent is sine of x, cosine of x. So if x equals 0, that cannot happen. So there's our asymptotes. And x is 0 at pi over 2 at the 90-degree intervals and 3 pi over 2. So let's draw our coordinates here. We have pi over 2 here. Let's make this pi, 3 pi over 2. This is negative pi over 2. And this is negative pi, negative 3 pi over 2. We'll go, this is 1, 2, 3, negative 1, negative 2, negative 3. So our asymptotes are at pi over 2. So I'll just draw an asymptote there. 3 pi over 2, like so. Pi over 2. 3 pi over 2. And now our basic general tangent of x, it looks like an x cube unit. So where our normal midway point there, here, is where the curve will bend. So it looks like an x cube. So you kind of go up, and here we'll bend it here and go up that way. So it looks like a positive x cube. In my mind, that's what it looks like. It looks like a positive x cube graph. And that is how you would do tangent of x. Cotangent of x, same properties. However, with cotangent of x, the asymptotes are going to be different, because cotangent is cosine of x over sine of x. So whenever sine of x equals 0, we have to have an asymptote. And that happens at 0 and pi. So if I were to quickly put in my units, alright, now put in my asymptote. So here, this will be 0, pi, okay, negative pi. There's my asymptotes. It's gonna curve here and the curve is going to be the opposite direction of the tangent. So it looks like a negative. Well, that's how I remember it. Tangent being your positive x cube curve. Cotangent is your negative x cube curve. So here, it will curve there. It will curve there. There. And so on. And that is our cotangent of x. Now let's try an altered one. Okay, so let's try it in altered one. Let's do one that says, let's do a change cotangent. So let's do 2 cotangent of pi over 2 plus x, or x plus, let's switch this around. X plus pi over 2 minus 1. Okay, so we got a lot of things going here. We have that 2 in front. We have that negative 1. Let's take it one step at a time. So using this, our cotangent of x, as our guideline here. So we want, let's do even another step. Let's make it negative 2. Negative 2. Okay. First things first. Everything here, that x plus 1, that's the first step. We'll focus on that. So let's say we have, let's put in our units. 3 pi over 2, pi, 3 pi over 2, negative pi over 2. That pi over 2 means the entire graph shifts left by 90 degrees. So our asymptotes, all we have to do is worry about moving our asymptotes. So our asymptote, which originally was on pi, is now at pi over 2. So that's how we would do that. Move it. So we'll just move all of our asymptotes over 90 degrees. So there's 1. The next part is where it curves was at 0. Well, now it shifts down 1. So a vertical shift of 1. So the new part is going to be here at negative 1. Now that negative 2 in front, that negative 2 in front means that it's going to be thinner. It's going to be a lot thinner. But it's still going to fall within the parameters. So the curve in the middle is just going to be thinner. And also the negative, it's going to flip upside down. So that's, you just got to draw something that's leaner, but it's going to fall within the same parameters. So it's going to be leaner, maybe more closer to a line like. Oh, not the best. Not the best picture, but you know, we're not professionals here. The other one is supposed to be more curvy, but it's okay as long as we get the right asymptotes and we get the right vertical shift and understand that that negative flips the whole thing upside down. So our curve is going to be going the opposite way. Then it's just fine.